Welcome students. Today we are going to learn chapter 14 statistic, and the topic of this chapter which we will cover in this session is graphical representation of cumulative frequency distribution. In our previous sessions we have learned the type of presentation of data in different tabular forms, meaning of arithmetic mean, mode and median, then calculation of mean using 3 methods, calculation of mode for different sets of data using the formula mode is equal to L plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H. Then calculation of median using formula median is equal to L plus N by 2 minus Cf upon F into H. In this session, we will learn how to graphically represent cumulative frequency distribution. Such representation is called either ogive or cumulative frequency curve. Let us take an example. The example says the following data gives the marks out of 100 obtained by 53 students in an exam. Convert it to a less than as well as to a more than type cumulative frequency distribution and draw both ogives, that is less than type, as well as more than type to obtain the median marks. The data says marks from 0 to 10 are obtained by 5 students, 10 to 20, 3 students, and so on. So, we are going to convert this distribution in less than type cumulative frequency distribution. How to do that? Let us look at this picture. We have from 0 to 10, 5 students. 10 to 20, there are 3 students. We want to form less than type cumulative frequency distribution table. For this table, we always take the upper limit of each class interval. And you know that in each class interval, upper limit is not included. So, we will write less than 10, less than 20, less than 30 and so on. We will not write less than or equal to 10, less than or equal to 20, right? Correct? So, let us form our first class interval, which is going to be 0 to 10, 5 students. So, how many students are there scoring marks less than 10? There are 5 such students. And if I ask you how many students have scored marks less than 20, it will include those students who have scored marks from 0 to 10 as well as those who have scored marks from 10 to 20. So, it will be 5 plus 3, that is 8. How many students have scored marks less than 30? It will be 8 plus 4, that is 12. How many students have scored marks less than 40? It will be 12 plus 3, that is 15. So, we can form this cumulative frequency distribution table of less than type taking the frequencies. So, to plot the ogive of this less than type cumulative frequency distribution, what we are going to do, I explained to you that we have taken the upper limit of each class interval, and these are the cumulative frequencies of that particular class interval. So, we are going to take on our graph paper along x axis the upper limit, which is in this case marks obtained by students. Along y axis, we will take the cumulative frequency, that is the number of students. So, our first point can be obtained if along x axis we take 10 and along y axis we take the cumulative frequency, which is 5 in this case. So, this gives our first point. Our second point, we take along x-axis 20 and along y-axis we take the cumulative frequency 8 to get our second point. This way we can plot all the points like 30, 12, 40, 15, 50, 18 and so on. After getting these points, join all the points to get your less than type ogive curve. Now, from this curve alone, we can find median. There are total 53 observations. So, half of 53 will be 26.5. We are going to locate 26.5 on y-axis. Then we need a point on this curve which has y coordinate 26.5. To locate that point, from this 26.5, we are going to draw a line parallel to x-axis, and the point where this line intersects our curve is our required point, which is marked red here. To get the median, we need x coordinate of this point. To get that x coordinate, we will draw a line perpendicular to x-axis from this point. You can see that this perpendicular line intersects x-axis at a point where the value of x is 66.4. So, our median will be 66.4. So, this is how we can find out median from the graph of less than type ogive. We can also form more than type ogive. Let us see how. For the same distribution, now we have the class intervals and frequencies. When we form more than type cumulative frequency distribution, we always consider the lower class limit of each class interval, and you know that lower class limit is included in that class interval. So, we will write more than or equal to 0. So, how many students have scored marks more than equal to 0? You know that all the students have scored marks more than or equal to 0. So, that means all the 53 students have scored marks more than equal to 0. If I ask you, how many students have scored marks more than or equal to 10? You can see there are only these 5 students who have scored marks less than 10. So, we are going to exclude these 5 students from 53. So, the number of students who have scored marks more than or equal to 10 will be 53 minus 5, that is 48. Similarly, we can calculate more than type cumulative frequency for all the class intervals, and you can see it is written in the table. Remember that your last frequency will be same as last cumulative frequency will be same as your frequency of class interval. Here we also say that more than type cumulative frequency of class interval 0 to 10 is 53. More than type cumulative frequency of class interval 10 to 20 is 48. The same we say for less than type cumulative frequency distribution also. Now, our next step is to plot the ogive, that is more than type ogive for this table. Let us see how. Remember that here we have taken the lower class limit of each class interval. To plot the graph or to get the more than type ogive, we will take along x-axis the lower limit of each class interval, which are actually the marks. As I have mentioned, For more than type, we consider the lower class limit. Along y-axis, again we are going to take cumulative frequency, which are in this case number of students. To get our first point, we will plot 0 on x-axis and 53 on y-axis. So, the first point will be this one. To get our second point, we will plot 10, we will take an 10 on x-axis and then 48 on y-axis. So, where we get our second point. After getting all the points, again we are going to join these points to get our more than type ogive. After getting this curve, again from this curve alone we can find out median. We will again locate half of 53, which is 26.5 on y-axis, get the point on the curve, take the x coordinate of this red point. So, the x coordinate of this point is 66.4. This 66.4 represents our median for this distribution. We can also plot both the ogives on one single graph paper. In such cases, the point where these two ogives intersect represents our point whose x coordinate is the median. So, to get the median by taking both the ogives, we first consider the intersection point of two ogives, then take x coordinate of that point of intersection, which again in this case turns out to be 66.4, and it communicates the same thing, that half of the data lies below 66.4 and rest half of the data lies above 66.4. Therefore, 66.4 divides the whole distribution into two halves, and it is our median. In our previous session, we have taken calculation of median for the same distribution. If you remember, we first found the median class and then used this formula to find the median where the symbols were taken from the median class. In that case also, the median turned out to be 66.4. So, it communicates the same thing. Let us take one more example in which we are not given directly the class intervals, but instead more than type cumulative frequency distribution table is given to us. Our example says the annual profit earned by 30 shops of a shopping complex in a locality give rise to the following distribution. So, there are 30 shops which have earned profit more than or equal to 5 lakh rupees. There are 28 shops which have earned profit more than or equal to 10 lakh rupees. The question asks us to draw both ogives for this data and hence obtain the median profit. So, as we need to draw both type of ogives, we need class intervals and then less than type cumulative frequency distribution table. So, first we will convert it into the form of having class intervals and frequencies. For that, let us look at the data. In this image, you can see more than or equal to 5 lakh, there are all the 30 shops. Then more than or equal to 10 lakhs, there are 28 shops. Then how many shops have earned profit from 5 to 10 lakh? Yes, it will be 30 minus 28. That means 2 shops. How many shops have earned profit from 10 to 15 lakh? That will be 28 minus 16, that means 12 shops. So, likewise, we can form all the class intervals and get the respective corresponding frequencies. After getting that table, our next step is, so here in front of you, you have more than or equal to type cumulative frequency distribution table. Then we have formed the class interval as well as calculated the respective corresponding frequencies. Now, next step, as we need to plot both the type of ogives, we need to get less than type cumulative frequency table also. For that, let us see how we have done it before also. So, we will take less than 10. You know that for less than we take the upper class limit of each class interval. So, here we are going to take how many shops are there which are earning profit less than 10 lakhs of rupees. You can see there are 2 shops. Less than 15, it will be 12 plus 2, that is 14. Less than 20, it will be 14 plus 2, that is 16. For less than 25, it will be 16 plus 4, that is 20, and so on. You can write cumulative frequency of less than type for each row. After getting these tables, now we can plot more than type ogive as well as less than type ogive for this distribution. Let us go for that. To plot more than type ogive, we will take profit along x-axis and cumulative frequency, which are number of shops in this case, along y-axis. So, here you can take the first point taking 5 on x-axis and taking 30 on y-axis. So, you get your first point. For second point, take 10 on x-axis and 28 on y-axis. So, this gives your second point. For third point, 15 on x-axis and 16 on y-axis. So, likewise, we can plot all the points and then we can join them to get our more than type ogive. To plot less than type ogive, again we are going to take upper limit of profit along x-axis and cumulative frequency along y-axis. We can get our first point by taking 10 on x-axis and 2 on y-axis. We can get our second point taking 15 on x-axis and 14 on y-axis. Likewise, we can get all the points of less than type, and after joining these points, we get less than type ogive. If we plot both the ogives on the same graph paper, then the point of intersection can be obtained. And remember, we have the median as the x coordinate of this point of intersection. So, here in this question, this point of intersection has x coordinate 17.5. So, our median will be 17.5 lakh rupees, which says that there are half of the shops which have earned profit less than 17.5 lakhs and rest half of the shops have earned profit more than 17.5 lakh of rupees. So, students, you have learned to plot both the ogives. Your assignment, I have given 2 questions. Your question 1 is, the following distribution gives the daily income of 50 workers of a factory. You can see there is daily income and number of workers. Convert it to more than and less than type cumulative frequency distribution and draw the ogives. Hence, find the median. The second question is, the following table gives production yield per hectare of wheat of 100 farms of a village. convert it to more than or less than type cumulative frequency distribution and draw the ogives, hence find the median. In today's session, we learn to represent a cumulative frequency distribution graphically as a cumulative frequency curve or an ogive of the less than type and of more than type. Then the median of group data can be obtained graphically as the x coordinate of the point of intersection of the two ogives for this data. I hope you have understood the plotting of ogives in both the types of data. Thank you so much.